Here we'll do another example where we find domains algebraically. This time we have x minus 2 over x squared minus 9. Here we'll introduce the fraction rule. The fraction rule says that the denominator of a fraction can never be 0. Therefore, to find the domain, we'll set the denominator not equal to 0. Now, we only do this if there are x's in the denominator. If there's no x in the denominator, we will not have any restriction. What we'll do is say x squared minus 9 is not equal to 0. To solve this, we will notice that this is a second power expression on the left. When we have a second power expression, the correct move is to try to factor it. We may also notice that both terms are perfect squares. We have x squared minus 9. 9 is a perfect square, and x squared, by definition, is also a perfect square. Because we have a negative in between them, this is what we call a difference of squares. In a previous video, we covered how to deal with difference of squares. We write two parentheses, write x for our first piece of both parentheses, and then figure out the square root of 9, and that will tell us the other piece. Square root of 9 is equal to 3, and so according to the difference of squares formula we covered previously, we'll have x plus 3 and x minus 3 for our factored version of the x squared minus 9. We'll set this still not equal to 0. Now we'll solve each piece separately. We'll say x plus 3 is not equal to 0, and x minus 3 is not equal to 0. If we solve the first piece, we'll subtract 3 from both sides and end up with x not equal to negative 3. If we do the same to the second, we'll have x equals positive 3 by adding 3 to both sides. Now we'll draw a picture to go with this. And we'll recall that in our inequalities, if we have strictly less, strictly greater, or not equal, those will appear as open circles. Therefore, at negative 3 and positive 3, we'll place open circles. We'll also place the infinities on either side of the picture. Now that we've placed our open circles, those open circles will cause gaps in the domain and split this domain into regions. We'll draw dotted lines to represent this, and we'll label each region A, B, and C. We'll look to region A, and we'll notice that region A begins with negative infinity and stops at negative 3. So we'll say our first region is negative infinity, comma, negative 3. Negative infinity will always get a parentheses, and because the negative 3 is an open circles mean to use parentheses as well. So we'll say negative infinity, comma, negative 3, parentheses. Then we'll say union to show there's another piece coming. Piece B will go from negative 3 to positive 3, and so we'll write in parentheses negative 3, comma, positive 3, and then union, and continue to region C. Region C will start at 3 and go to infinity. And we'll say 3 to infinity for the final piece of our domain. This is how we write the domain of any fractions that have x in the denominator.